Is it recording my face? So let me see something. How do I record? Okay, so this is attempt number three. I had recorded two other videos, but they didn't have my camera on. And this one has the camera on. Okay, so my name is Jesus Acosta, and I'm gonna be doing um question 11 from the extra credit project. And the question is f of x equals ln parentheses x plus 1 parentheses where x is 0 comma 4. So, okay, so the first thing I'm going to be doing is I'm going to be defining continuity and limits. So what continuity means is that the function is smooth and it has no breaks or jumps. It's just a smooth curve. And the natural log is defined from x plus 1 is greater than 0, so that f of x equals ln x plus 1, which is continuous for all of x is greater than -1, since our interval is 0 through 4. And then the function is continuous throughout this range. So to discuss the limits, I have what I did was I got the function and plugged in 0 and 4 on as an x on the problem. So this is an example. I don't know if it's going to show, but of course it's not. So what you do is plug in 0 where this x is right here. X. You just plug in the 0, which when you plug in the 0, which x f of x of 0, it's going to be 0. Anything times 0 is 0. And if you plug in the 4 for x, it's going to get you 1.609. And that's going to be those those are going to be the limits of those 2 points. Okay, and to find the first derivative of f of x equals ln of ln parentheses x plus 1. That came out to be um 1 over x plus 1. So what I did there was use the chain rule to find the first derivative. And to find the first derivative, what I did was put u instead of x plus 1, I replaced it with u and found the derivative of that, which gave me 1 over x plus 1. And that tells us the slope of the function at any point, which f prime of x is greater than 0 for all of the points between 0 and 4. 0, comma 4, whatever. So the function there for the first interval is always increasing on that interval. So for the second derivative was I ended up using the quotient rule. And using the quotient rule right here, ended up just plugging everything in using the quotient rule, the formula, and I ended up getting -1 over x plus 1 parentheses squared. which is it's always negative. The second derivative is always negative, which means that the function of a concave down for all x in the second interval, which is the second derivative, there's no inflection points because the second derivative does not change the sign. Okay, and we go to the second one. Okay, so the integral to find the in, let me see. Give me a second. Oh, I think, okay, so to find the defined indefinite integral, you compute, you use the integration by parts. So log u dv equals uv minus, that's basically the formula. So you set u to ln parentheses x plus 1, which is this right here. And then you do du equals 1, du equals 1 over x plus 1 dx, and then the v is going to equal x. So what you do there, you just substitute into the formula. So what you do is substitute everything into the formula. As you see here, you just substitute everything inside of it. Then you simplify it. Now you rewrite it. You rewrite the x. So what you do is replace x with all this right here. So then you rewrite it all. Then you solve it. And this is what I got. I don't know if it's right, but I got it. Then you substitute it back. Substitute the ln parentheses x plus 1, you substitute it back into the problem, and then you simplify it, which you end up getting, hold this right here. Make sure I made sure to add the plus c. I think I remember seeing that in a lecture. Okay, and then you do to find the integral, you do, this is going to be the integral of 4 over 0 ln. So then you use the other, this is what you got from the other problem right here. This is what you got from the indefinite integral. Then you evaluate the x plus x equals 4 into the interval here. Plug it in again. Then you get 5, 5 ln parentheses 5 minus 4, if I'm not mistaken. Yeah, right here. You get that, and you substitute in the 0, which 0 times anything again is gonna be 0. Then you subtract both problems. So you subtract whatever you got from here on the problem. So you subtract, you got, you bring this problem down, and then you add the 5 ln parentheses 5 minus 4. I don't know if I can move it. I took a picture pretty bad. You just add it over here. Again, this is the 0 from when you evaluated the 0 on this side. And the L, so L, L, approximating the ln of 5, which this part, wait, sorry. So it's going to be messing up, sorry. Ln of 5 is going to be, my goodness. ln of 5 is going to be 1.609 is what we got from the limit before when we first started. And so when we're subtracting everything, simplifying everything, we ended up getting this right here, which is approximately 4.045. And that's going to be the area when the concave is going down, if I'm not mistaken. So yeah, so the function of f of x equals ln parentheses x plus 1 is continuous and increasing and concave down on the interval 0, 4. The derivatives help understand its like slope of the problem. And what else do I have to go? Yeah. Thank you for watching.